See, in the morning class, what we have studied? At the last 10 minutes, what we studied? Isomerism. Okay, here I have 31 questions. I have collected 31 PYQs only. Okay, this PDF contains 31 PYQs. So you just solve all these questions. Okay, first of all, let's start our discussion with morning isomerism question first. So tell me, what type of isomerism exhibited by these compounds? Tell me. First one, why A2? Linkage isomerism possible when we have ambidentate ligand. So what is this ambidentate? Here we have nitro now, so it can be ambidentate. So it can show linkage. Next one, coordination isomerism shown when we have two coordination complexes within the compound. How many coordination pairs are required? 2. So here only one complex with that. So it means, what is our answer? C. So C4. Next, what about D? Now if I change the water molecules outside the sphere, inside the sphere, what it will gives you? Solvate. So D1. Next, what is remaining? I can change Br inside, sulfate outside. That compound is what? Ionization. So now as per that, what is your answer? C. Okay. So before moving to the next question here, okay, we will solve all these questions. But before that, I just wanted to complete little more topic we are pending with. We will finish that. See, structural isomerism is done. Next one is stereoisomerism. Stereoisomerism is of two types. How many types? Two types. What are those? Stereo isomerism is of two types. One is geometrical, another one is optical. Okay, so here geometrical, just simply we will say cis-trans isomerism. What is that? Cis-trans isomerism. In order to show this cis-trans isomerism, we will be saying if same groups are same side, cis, like that, na? Okay, so now what are the coordination numbers we know? Tell me. Coordination number 2, coordination number 3, like that, na? So with coordination number 4, like geometrical isomerism starts from where? Coordination number 4. Even optical isomerism also starts from where? Coordination number 4. With coordination number 4, what are the two possible geometries we have? One is tetrahedral, another one is square planar. Okay, so now geometrical isomerism exists only in square planar complexes. In which complexes we will see geometrical isomerism? So here only we will see this cis-trans isomerism. Cis-trans isomerism is seen in which case? Square planar only. Okay, the next one, with coordination number 5 we do not have that. With coordination number 6, again what is the geometry we have? Octahedral. So in octahedral also we are going to study about geometrical isomerism. That is what? Cis-trans isomerism. Cis-trans isomerism. So now what are the two things we need to focus? One is square planar, second one is octahedral. For this particular cis-trans isomerism. Okay, let us do it with square planar first. See, first of all, they will give you 4 complexes. They will ask us identify in which of the following geometrical isomerism is possible. First, what to check? Whether it has a square planar complex or whether it can be a tetrahedral. So what I told you, it is possible only in square planar, and if it is octahedral or any other thing. So we have geometrical isomerism in what are the cases? Square planar, octahedral. First thing is this one. The next one is, see, I am saying there is a metal like this with 4 ligands. If all 4 surrounding ligands are same, can we say here geometrical isomerism? Like which is cis, which is trans, can we say? No. So if there is a metal M with 3 same ligands, can we say here? See, square planar means what it will be like? Square planar. See, there will be a metal like around this, like a square geometry we will be having. So at all these corners what we are going to have? Ligands. Yes or no? Okay. See, if all these ligands are same, how can I say this is cis or trans? We cannot say now. Even if there are 3 same, one is different. Can we say here no? B is there. With what I can say it as a trans or cis? Here also not possible. If there is a complex like Ma2B2, Is it possible now? Yes. Now I can put both B's like this, so it can be cis. Okay? See, in organic chemistry, there will be double bond like this. We will be seeing like on two different carbons, AA is there means cis we are saying. Here, central atom is one, and that only you need to check. If they are with square planar means, what is the angle between these two lines? Here. So, in a square planar, if the two same groups are at 90 degrees, you can say it as a cis isomer. What is it? Now, with the same formula, I am writing one more example. See, M, BB, AA. How it is? Trans isomer. Is this clear? It should be like this. So, with Ma2, Ma2B2, we have cis isomer, trans isomer. So, how many possible isomers are there? 2. Is this clear? Next, if Ma3B3, not possible. Here also, not possible. Is this clear up to here? Next, what is the possibility we have? I can change it like Ma2BC. Yes or no? Just change the types of ligands, that's it. So now what I can put here, both A's, cis, both A's, ikkada enni A's unnayamma? See, M anedi metal, M is a metal. ABCs are representing ligands. What they are representing? Ligands. For example, platinum, all platinum tetra-coordinated complexes are square planar complexes we studied in the last class, okay, in VBT. Okay, so there I am writing ammonias as 2, like 2 ammonias are there, 2 chlorines are there. So this is of which kind out of these 4? Ma2, B2 type. So how many possible geometries for this? 2. Like this you can understand. Is this clear everyone? Okay. So now what I am doing is I am putting A2, BC. It means how many types of ligands are there? 3 types. So here you can put 2 A's cis to each other and trans to each other. Right now. So it means here also how many possibilities are there? 2 only. Is this clear everyone? Okay. Next one is, how can I change now? What is the type I can take here? M, A, B, C, D. This kind of complex now? So now here you can check. A, B, C, D I am taking. See, what is the relation here? I can say with respect to A, what is trans? A trans C. A trans C. Now what I am doing is, I am fixing the position of A and changing, I am altering the positions of this B, C, D. So now what happens, tell me? M, fix the position of A. Now change these positions, like rotate it. What happens? Here D is there, now D comes here. Here it goes B, here it comes C. Now here what is trans? A trans B. Yes or no? Like that, once again you flip M. Yeah. Where is D? This is D. Okay. Okay, next. This one you tell me. Again you flip. Here it is D. C here. B here. Is this clear everyone? Okay. So A trans D. Clear everyone? So if you rotate one more time, what happens? That is nothing but first one. It means for ABCD type, how many possible geometrical isomers are there? 3. That's it. Remember this. First of all, in order to show geometrical isomerism, complex must be square planar. With what type of ligands? Either Ma2B2 or Ma2BC or MABCD type. Is this clear? For A2B2, 2. A2BC type, 2. ABCD type, 3. Is this clear everyone? Okay, right, perfect. Now, till now, the discussion is over for which one? Square planar. Tetrahedral, not possible. So, the next geometrical isomerism we need to discuss about octahedral. Before that, here what type of ligands I have taken? These are monodentate ligands now. We also have bidentate ligands. Yes or no? Bidentate ligands are there or not? Let us take, there is a metal M. There are 2 bidentate ligands. Like this I am taking. AA means what? Like ethylene diamine, do you remember? What is the structure? CH2, CH2, NH2, NH2. Now what are the two donor sites here? N and donor, no? It means simply I am mentioning AA means it's a bidentate ligand. Okay, so AA means both donor sites are same. So I am taking this as one time and one more ligand as BB. Will it show or not? See, I can put AA over here. It means you are putting this ring here, I mean this complex here, like this it becomes. Here BB you are putting, like this it becomes. What is this cis or trans? AA same side kada, cis ante. Now you try to draw the trans structure. ఒకసారి ట్రై చేయండి, డ్రా స్ట్రక్చర్ డ్రా చేసి. See M A, I should put A here. Is this possible to make a chain like this? So it means transform won't exist. It means geometrical isomerism won't exist in this. Is this clear how to identify whether it is possible or not? They will give 4 compounds. In which of the following geometrical isomerism is possible, they will ask. Do you got the concept how to decide? Yeah. Now check what I am doing. AA B2. What happens here? See, this B2 means it's a monodentate ligand only. AA I can put here cis, but trans is not possible now. So here also it is not possible. Let us change in some other manner. So I am taking here AB, here AB1 X2. Tell me here M AB XX. This is a chain. Is it possible here? Not possible. Okay, now what I am doing is I am writing this as AB. This is fine, but here XY I am writing. Is it possible? See, AB it is fine. Here X and Y. See, what I can say here is A cis to X. What I can say? A cis to X. Next possible structure what I can make? You interchange these two things. Y cis to A. A cis to, I mean these are cis. Now Y is cis to A. Like this it is possible now. Is it possible or not? So you can write here it as 2. You are getting now? If they give some random structure, random formula, how can you identify? Try to write its structure and just check whether geometrical isomerism is existing or not. Is this clear everyone? Yeah, perfect. Next. Square planar is done. Next one is what? Geometrical isomerism in octahedral. See, octahedral means how many ligands should be there? 6. So if there are all 6 are same, is it possible? All 5 are same, one is different. Is it possible? No. The next one is here it is not possible. No GI here in these two cases. M A4 B2 type I am writing. Just check here, is it possible or not? Yeah. See, octahedral means how it will be? M in the middle. 1, 2, 3, 4. Like a square first. One above line, one below line. Like this now? Okay. Now, try to insert A4. A4. Okay. Now try to insert B's here on white color lines. All A's here. Okay. Observe here. This is this yellow color plane. This is what? Yellow color plane. It means it's a square. Don't say it is rectangle. Now we consider it as square. Okay. Above one line is there. Below one white color line is there. Now what is the angle of this above line with all these planarity molecules? Between two of these lines, between two A's, how much? See this one and this one. See, it is like this. What is the angle? 90. So all 90 degrees angles are called cis to each other. All 90 degrees are what? All 180s are considered as trans to each other. What is that? All 180 degrees are considered as? Is this clear everyone? 90 degrees is how much? So now with respect to B and A, what is the angle we have? So B and A, how they are now? Cis to each other. And this B's are how they related to each other? Trans. So I can say this as a trans isomer. Which isomer? Trans. Why I am saying trans isomer? Because B trans B. Yes or no? B trans B. So like that you try to arrange the cis isomer. It means how can I place? So now what I can do now? Bring this B somewhere on the plane. Let us say here B I am placing. So here I can place now A. So remaining positions you can place B, A. So now tell me, between this B and B, what is the angle we have? 90. 90 means B, cis B I can say now. So this is a cis isomer, this is a trans isomer. So for Ma2B2 type, geometrical isomerism is possible or not? Possible. How many are getting? 2. Like this we need to identify. Okay. So for Ma6, Ma5B, is it possible? No. Like this I will give you a table, just remember the table. Next, what is the first possibility I have given? A4B2. Next, Ma4BC. Next, see what I am doing, just observe here. First what I written? A4B2. Next I changed this as BC. Next what I am doing is Ma3B3. Next Ma3B2C. Next Ma3BCD. Next all 3 over now. Next A2, B2, C2. Okay. Next A2 as it is, B2 as it is, this one becomes CD. Next A2, B, C, D, E. Okay. Next A, B, C, D, E, F. Is this clear? These are the possible ways now. You come in the systematic way only, like this only. First one is what possible here? Ma2B2. Next B, expand it as BC. Next all these things are over, make it a short one. A3, B3. Next here, extend this. B2C2, BCD. Over. All 3 over. Next come to 2. A2, B2, C2. Is this clear how we are writing these? Okay. So in Ma4B2, what are the possible isomers we have? 2. One is cis trans. Like that here it is 2. Here also 2. Just remember these numbers. Here also 2. Here how many 2's over? So here 3. Just remember. Next it will be 4. Here it will be 5. Next here it will be 6. After 6 directly it is 9. How much? After this it is directly 15. If you want you can write, you are going to get this many possible isomers. Okay. So what are the numbers? First 3 are 2's. First 2 are 3 over, 2 over. Next 3, 4, 5, 6, 9, 15. But you should remember in this model only, then only it will be perfect. See, now I am giving a complex here. Cobalt, NH3, tries Cl3. 2. This is of which model? A3, Ma3, B3. 2. So the 2 isomers are called facial isomer, meridional isomer. What are the 2 things? One is facial. Why I am saying this particularly means it is important. Ma3, B3, how many are there? 2. First one is called facial, another one is called meridional. So facial means around the metal atom. Around the metal atom. So you just try to imagine here, here, here. It means one of this phase is occupied by same type of ligands. Like one phase is occupied by what? Same type of ligands. That's why we are saying it as facial. In meridional case, it will be different. They won't occupy this one somewhere remove from here and insert somewhere over here. So that becomes what, like this. So that is considered as meridional. Okay, for MA3, B3, how many are possible? 2. Like that, MA4, B2. MA4, B2, 2. Next, MABCDEF, 15. Okay, remember these numbers. Fine. Next, they will ask you about this one now. These are all what? Monodentate ligands. What they are? Monodentate ligand. So bidentate ligands I can write like MAA 3. Is it possible in this case? Geometrical isomerism. All of them are A's only now. We cannot differentiate them. So not possible. Next, MAB3, is it possible here? Here also not possible. Which one is not possible? Geometrical isomerism is not possible. Next, what I am doing is, I am converting now MAA2's XY. How many bidentate ligands are there? First tell me. AA2's means 2 bidentate ligands, XY are monodentate ligands. Next, MAA2 X2. Is it possible in this case? Once try to write the structure M. Again, these models are important. AA2s are there now. So now what I am doing is, I am putting A here and here, making a chain. A here and here, making a chain. Now above, below. Here one monodentate ligand, here one monodentate ligand. How they are? Trans to each other. Now X and X, how they are? Trans to each other. Next, what is the other possible thing I can make? M. Putting X is X and X in the plane. It means how this X and X are oriented now? And here one A, here one A. Here one A, here one A. How they are? Cis to each other. All of them are cis to each other or not? See. With respect to X and X only you check. How they are? This is cis, this is trans. So MAA2 X2 is possible. What about this XY? Here also possible, because X and Y I can put cis to each other, trans to each other. There also it is possible. Is this clear? Like this you need to identify. Okay. So have you made this table? This one? Do it fast if not. Make it fast. Okay, we will continue about optical isomerism in the next session. It means next session means whenever we have some small time, we will finish that, because